Which leads us to the last part of the problem, and the one that's probably the most complicated part, which is why it's last. How far from the base of the cliff will the ball land? And so in order to do this, I'll tell you that we've already done a lot of the groundwork, the hard groundwork that we're going to need to do to solve this problem. And so let's just kind of summarize what we already know. We know that it goes up this high and then lands here. And we know that this height is, what did we say, 134 meters? And we even calculated the time it took to go up. What was that? The 2.7. So we've done a lot of the groundwork here. So how in the world can we find, and let's kind of draw it, this? How can we find that? So what is the formula for the range? What is the formula for the x distance? Well, is the x accelerated or not accelerated? It's not accelerated. What's the formula for a distance and a velocity if there's no acceleration in it? Just v times t. So vx times t is all we got to do here. And in fact, we already have the vx. We found that in the very first problem. What was that again? What? 34.3? So all we've got to do is multiply that by the time, and we'll be done. Can we use 2.7? What was 2.7? Do you remember what that was? That was the time from where it was launched to the top. Is that the distance? Is that the x distance we want? No, it's not. We want the entire x distance, so we're going to need to know the entire time that it's in the air, which we don't know. We haven't calculated that yet. However, we do know something. This is one of those times, and all of these problems kind of work this way. There's something we want to know. We want to know in the x, how long was it in the air? We want to know how long was it in the air. But that problem, how far did it go in the x, is dependent on how far it was in the air, how long it was in the air, and that depends on the y. And so the two are interrelated. And so is there anything we can do now to find the time, given that we know that it took 2.7 seconds to get to the top? Can we calculate the time to fall? Can we do that? Yeah, we ought to be able to do that. We've done problems like that before. So let's isolate. What do we know? Let's just cut it up into the second half of the problem. What is the velocity in the y direction? Only care about the y right now, because the y is what's going to determine how long it takes to fall. The x isn't going to impact that unless it has wings or something. And so the y, what's the y velocity here? Let's call that the initial at this point. What'd you say? 0. That's right. And what we know, the initial y, we know the acceleration, and we know the distance, don't we? The distance in the y. Well, I'm pretty sure that we can probably find a time. That sounds like d equals vit plus half at squared, doesn't it? But you got to be careful. You got to be careful. You have your x formulas that deal with horizontal things, how far it goes in the x, the horizontal velocity, those kinds of things. And then you have your vertical formulas, and those are your vit plus half at squares, your vf squared equals vi squared plus 2ad, all those accelerated formulas. All the accelerated formulas will be what we use when we're dealing with verticals, and this guy is what we'll be using when we're dealing with horizontals. And so the dy then, dy equals vit plus half at squared, can give us the time, because the y distance is 134. The initial velocity in the y, we said, was 0. and 1/2 of negative 9.8 t squared. I suppose this d should probably be negative as well because it's going down, right? So the displacement is negative. So we end up with 134 equals 4.9 t squared. So 134 divided by 4.9 equals t squared. So divide 134 by 4.9 and then take the square root. And what is the time that we get there? What's that? 5.2? Okay, now we are very close to being ready to solve the final problem, which is how far did it go in the x direction? We said we could do that by taking the x velocity, which we know, times the time, and the time, be careful, what is the time that we're going to use here? Am I going to add the 2 times or not? Let's look at it. We want to know the distance that it went from here. I'm going to use a new color. I keep drawing in green. From here to here, right? That's the distance we want. So we're going to use the x velocity while it was going from here to here. And we're going to use the time it took to go from here to here, right? So is the time it took to go from here, well, I guess really technically from here to here, is that time just 5.2, or is it both of them together? It's both of them together. So it's going to be 5.2 plus 2.7, or 7.9, right? 7.9. 34.3 times 7.9 is what? How many? 271. So the distance that it goes is 200, I'll just call it 270 meters, which is the range.